Welcome to Study Loop.
Okay, so the way neon lamp works here is we have the battery voltage or the EMF voltage, and then we have a capacitor. So the capacitor is charged through the circuit, so through the RC circuit, and once the capacitor, and we know that the threshold voltage is 90 volts. So once the capacitor reaches 90 volts, it will start discharging, and then it will try to discharge through the neon lamp because it has lower resistance than this guy, so it will discharge through the neon lamp and the neon lamp will flash. So uh, if we want to know what time the light will first flash, we have to find out the time this capacitor takes to reach to the threshold voltage, which is 90 volts. Now we know that the equation for charging is V equals the EMF voltage times 1 minus exponential T over RC, where RC is the time constant. And from there, if we solve for T, we'll get something like minus RC times log base E 1 minus V over the EMF voltage. So in our case, V is V naught or the threshold voltage. So we know all the values. We know R is this guy. So this R is this guy. C is 0.15 microfarad. Epsilon is 105 volts and V naught is 90 volts. So if we plug in all the numbers, we get our time as 0.686 seconds. So in 0.686 seconds, we'll see the first flash. Now, in part B, it says if the value of R is increased, will the time you found in part A will in part A decrease or increase? So we see R is proportional to T. So that means the other quantities, the capacitance, the threshold voltage or the EMF voltage is not changing. So that means we have a relation between T and R, which is a proportional relation. So that means if R increases, our time will increase. So that means it will take more than 0.68 seconds, 686 seconds to flash. So our time will increase. In part C, uh, we have to explain why the flashing of the lamp is very brief. So what happens here is the neon lamp is nothing but just a lamp filled with ionized gas, right? So this is a gas filled, sorry, it's a lamp filled with ionized gas, filled with ionized gas, and since it's just a lamp filled with ionized gas, it has very low resistance. And if the resistance is really low, that means the charge will discharge through the lamp very quickly. So since it's low resistance, that's why short discharge time. All right. So in part D, we have to explain what happens after the lamp flashes for the first time. So if the lamp flashes for the first time, that means whatever charge this capacitor accumulated, that's gone. So now we have zero capacitance here, and then it will start charging again. So that means, and as we calculated in part A, that it takes 0.686 seconds to charge the capacitor. So that means after the first flash is gone, after we see the first flash, we have to wait 0.686 seconds to see the second flash. So, and it will keep on going, doing that way. So it will, after 0.686 seconds, it will again flash, and then the capacitor will discharge again, and that after 0.686 seconds like later, we'll see another flash. So yeah, that's what happens when the lamp flashes for the first time. Thank you.